Hi. We've already created a multiple linear regression and have calculated its adjusted R-squared. The value we obtained for the latter showed one of the two variables does not increase the explanatory power of the regression. Therefore, if we can identify which one and remove it, we could further simplify our model. The question is how to detect the variables which are unneeded in a model. There's actually a whole process created for that purpose. It is called feature selection. Feature selection is a very important procedure in machine learning as it simplifies models, which makes them much easier to interpret by data scientists. Through this process, we gain improved speed and often prevent a series of other unwanted issues arising from having too many features. Feature selection is actually an idea you are already familiar with. In fact, when we are dealing with stats models, we were given the p-values of the features, which we later used to determine whether the independent variables were relevant for the model. Recall that if a variable has a p-value above 0.05, we can disregard it. Okay, so how can we find the p-values in SKLEARN? Well, this is one of the cases where SKLEARN manifests itself as a machine learning package rather than a statistical one. There is no built-in method we can call to get them. Therefore, we must find a workaround. A very close concept is available with the feature selection module from SKLEARN. It is called F-regression. F-regression creates simple linear regressions of each feature and the dependent variable. For our GPA SAT example, it would translate into two regressions, one where we predict GPA with SAT and one where we predict GPA with RAND 1, 2, 3. Then, the method would calculate the F statistic for each of those regressions and return the respective p-values. If there were 50 features, 50 simple regressions would be created. Note that for a simple linear regression, the p-value of the F statistic coincides with the p-value of the only independent variable. Therefore, this method is precisely what we need. Okay, let's see it in action. First, we must import F-regression from sklearn.featureSelection. Second, we can call the method F-regression with arguments the features contained in X and the target contained in Y. And that's all. Running the code, we find that there are two output arrays. The first one contains the F statistics for each of the regressions, while the second, the corresponding p-values. Generally, we are interested only in the p-values, so I will declare a new variable called p-values, which will be equal to the element at position 1 of the F-regression output. Okay. Now, you can't help but notice that the p-values are written in a strange way. This is scientific notation not everyone is aware of. Here's how to interpret them. E minus 11 means times 10 to the power of minus 11, or divided by 10 to the power of 11. Similarly, E minus 1 means times 10 to the power of 1, or simply divided by 10. Even for experienced users, it's not always intuitive to look at the scientific notation. Thus, I'll round the numbers to only 3 digits after the dot. Let's type p-values dot round parentheses. In the parentheses, we can choose the number of digits after the dot we want to round to. 3 is completely enough for p-value interpretation. Our new results are 0 and 0.676. There you have them, the p-values of the two features. The first one refers to the first column of X, while the second one to the second. Therefore, the p-value of SAT is 0.000, and that RAND 123 is 0.676. With your prior regression analysis experience, you can easily determine that SAT is a useful variable, while RAND 123 is useless. Great! So, we have found the p-values of the regression through this simple workaround. What should be noted, though, is that these are the univariate p-values, or the p-values reached from simple linear models. They do not reflect the interconnection of the features in our multiple linear regression. Therefore, F-regression should be used with caution, as it is one bit too simplistic for more complicated problems. All right. In the next lesson, we will quickly arrange this new information in a summary table. Thanks for watching.